Okay, so the peak voltage of a half wave rectifier is given as 10 volt. So they're saying there is no filter. Then they're asking you to find the DC component. I think they're talking about the DC equivalent. To do this problem, we need to understand some basics. So look at this. This is a AC signal and this is a ideal DC output, which means it should be straight like this. So I'm sure all of you are familiar with half wave rectifier and full wave rectifier. So half wave means the lower halves gets cut off, actually cuts. So this is not going through the diode, whereas in the full wave rectifier you will see the ripples like this. And what does a capacitor do? When you put a capacitor in the load resistance, what will happen is when the capacitor is getting charged, when the current is coming in, the capacitor will get charged. And when the current is dropping down like this, the capacitor will supply. And that's what, the line here shows that the capacitor is supplying the energy. So that means understand it carefully. You know that capacitor stores energy and then gives it back. Inductor stores in the form of magnetic field. Capacitor stores in the form of electric field. So that means it stores energy and then gives it back. And that's what we are seeing here. That means we are trying to achieve this straight line. But still, you can see it's not 100% perfect. But as the capacitance values are changed, you can get smoother curve. I have a separate video showing the cathode ray oscilloscope and the signals. So that's an interesting one for you to watch it. Coming back to the question, what they are saying here is in the half wave rectifier, there is no filter, which means it's going to be like this. So the V average is, you have to calculate the area under this curve. So let me use my pens here. So look at this carefully. I want this area. But of course, I don't want the sinusoidal wave which is coming over here. So that means we don't want that. So that means it's going to be 0 to pi. But then we want the average for from here to one full cycle. That means it should be 2 pi here. That means if I want to calculate the average of your marks, what I will do is I will add all the 5 subject marks, which means I'll get the total, and I will divide by 5. So here, adding is something like integration here, right? So you are integrating all the area under this curve, 0 to pi. And then you have to divide by the base, which is the time period, which is 2 pi. So you are dividing it by 2 pi. So do this math, you should be getting V naught by pi. Similarly, if you do it for VRMS, it will be V naught by 2. In the case of full wave rectifier, we will do the same thing 0 to pi. But then this same curve is repeated over here. That means we simply do multiply by 2. Okay. From your mathematics knowledge, you should know that if I do 0 to 2 pi, what will happen is, since you are taking sine theta, the sine theta will show a negative curve on this side. So the positive area and the negative area will cancel. To avoid that, right, in the applications of integration, you must have studied that. In this kind of situation, it's better to use 2 times 0 to pi. Okay, I hope I'm trying to give you a basic idea. So if you want, you can access this notes in the link which I have provided in the description. Once you understand this theory, this problem is very easy. Okay, I think we saw V naught by pi for V average, which means 10 divided by pi. So this should be the correct answer. I was wondering VRMS happens to be V naught by 2 according to the earlier notes, but that option is not there. because I know VRMS is what will give you an answer which is close to DC current. So I'm just wondering why that option is not there. Anyhow, this is the option we have. So I'm going to choose this one.